Okay, pull up my monitors here. Move this, switch. Okay. Okay. Let me turn. Okay, so a bit different time than usual. The thing is, I have lots of stuff to do with the family this afternoon, and also this evening probably. So I figured let's just do it now when I have a little pocket of time to get this done. Let's see. So yeah. I just created a thumbnail, etc. Just getting back to it. I finished yesterday without getting the second star, and at the end I was doing all sorts of things, and I think I can show some of it here. I think this was one of the last things I tried. Let me run this. So what I did here was, no, that was the one that didn't work, or was it? Oh yeah, this was the one that worked. As you can see, the numbers that it generates here, if I offset them, I can successfully shift them over. And that's basically where I ended yesterday, to just figure out how can I have those numbers, move them over, etc. So I had some sleep, and I did a bit of reading, and just now I was like, okay, can this work? So I wrote some code and I cleaned it up and I put it into a function. Let me just throw away all of this temporary code. And I could probably also clean up this part, because I tried so many things. I might want to do the binary search and put that into a function later, because I've never written that before. I did it live yesterday. So let me get rid of that. So basically I now have a function that says reproduce. And what it does, it just builds the string part by part. So it will see if we can generate the last digit. And the fun thing is that this doesn't work for number 4, because that takes a whole lot of combinations. Good morning, Amate. Hello. So if you want to reproduce the last digit as a 4, as you can see here, it spits out 6 twice, but not a 4. And that basically means that you need a bigger number to reduce that. And you can see that also when you run this. So when I run this, did I run it? Let me just throw this away, do it like this and run it. You can see it comes up with the first part very easily, usually within like the same set of numbers. But to reproduce this second one after the previous one, it needs a whole lot more, a way bigger jump in numbers. And then here it needs another big one. So I think this is like, it takes like 9 million something, because I just did this morning and verified that it works, but I haven't submitted it yet. So this one takes a little bit, and then it gets to the end. So then it will do the rest. So I figured let's get the last star together. So as you can see here, boom. So there's a big step here. For yeah, like nearly 10 million it needs to add, and then these are relatively small steps. So this should be our answer. Yeah, so woohoo, second gold star for yesterday. I was so tired in the end. So I think I got down to like 3 people watching when like my second monitor is probably one and a Marte. So I think I wore everybody out at the end yesterday. But hey Black Eye, good morning. So yeah, so I don't know who heard, but usually I stream in the evening, but today I have lots of stuff with family, and so I don't know if I'll be able to make it and have enough energy to stream it. So I was like, okay, I'll do it in the morning and do a bit more work in the evening where I have more freedom to like do it in chunks or zone out a bit. I need to be a little bit more fresh to do this. So yeah, let's start reading day 18. Ram Run. You and the historians look a lot more pixelated than you remember. You're inside a computer at the North Pole. Just as you're about to check out your surroundings, a program runs up to you. This region of memory isn't safe. The user misunderstood what a pushdown automaton is, and their algorithm is pushing whole bytes down on top of us. Run! The algorithm is fast. It's going to cause a byte to fall into your memory space once every nanosecond. Fortunately, you're faster, and by quickly scanning the algorithm, you create a list of which bytes will fall, your puzzle input, in the order they'll land on your memory space. Your memory space is a two-dimensional grid with coordinates that range from 0 to 70, both horizontally and vertically. However, for the sake of example, suppose you're on a similar grid with coordinates that range from 0 to 6 and the following list of incoming byte positions. Okay? For each byte position is given as xy coordinate, where x is the distance from the left and y distance from the top. You and the historians are currently in the top left corner of memory space at 0, 0 and need to reach the exit in the bottom right corner at 77 in your memory space, but at 6, 6 in this example. You'll need to simulate the falling bytes to plan out where it will be safe to run. For now, simulate just the first few bytes falling into your memory space. Like I said, today is a fresh air compared with yesterday's. Okay. As bytes fall into your memory space, they make that coordinate corrupted. Corrupted memory coordinates cannot be entered by you or the historian, so you'll need to plan your route carefully. You cannot leave the boundaries of the memory space. Your only hope is to reach the exit. In the above example, if you were to draw the memory space after the first 12 bytes have fallen using a period for safe and hash for corrupted, it would look like this. You can take steps up, down, left or right. After just 12 bytes of corrupted locations in your memory space, the shortest path from the top left corner to the exit would take 22 steps. Here, marked with 0, is one such path. Simulate the first kilobyte, 1024 bytes, falling into your memory space. Afterwards, what's the minimum number of steps needed to reach the exit? Okay. Okay. I wonder if there will be like a constraint where it forms as you fall or something, but I think you can just... So it will take 12 here. This is more than 12. Interesting. So how long is the puzzle input? We'll figure it out in code. Okay, let's just start. Boom. Day 18. You can just front align this. So input 2 lines dot select split comma as int32s as value tuple. So this will then be like a list of int x, int y. Like this. The only thing that I wonder now is if I should make this. I should make this into grid locations actually. And I wonder if it can do this. Do I have a... I think I have an implicit conversion there for yeah, AB. So that will be row and column, but that's inversed for me. So that won't work. So I have it implicit, but it expects it in the other direction. So this is column comma row, and this will parse it as row column. So I need to just do like this. I need to swap it around. Nineberry says, did you finish part 2 yesterday? Yeah, I just did it at the start of the stream. Basically, I have I deleted all of the code by now. I showed it at the start of the stream, so you can go back on YouTube if you want. I'll go over it quickly. Basically, I ended with like finding that if I have the values and I shifted them over, I could keep them if I did like the opposite. So I could shift over whole rows of values if I shifted it over. So then I did a naive thing that would just take the number, shift it over, and then try to find the next one. And there's basically two spots in the value that take a long time. There's one step that takes like 10,000 iterations, or 10 million iterations. So I'm sure there's a cleverer way, but this worked. So I will go to Reddit and see what everybody else did to see if there's a clever way to do it really fast, but I don't have the mind space right now to do that because I have lots of stuff on my plate right now. Let's see, so this is everything parsed. And I should just run this to make sure that it's correct because I need to swap this. Let's see, what did I want to do? Oh yeah, I need to set up the... I already did that. Okay, I can just run this now. So now parsed, the first one should be col 5, row 4, so that is fine. I just, I set this up the other way to do x, y-x because that's like in the way that I use the maps. It makes more sense for me, but yeah. I should probably, since it's for Advent of Code, I should probably have it the other way around, but it's fine. It's parsed, so we can share this here. Like this. Let's see, there was an answer here. We had 1024 for our actual input. So we do P1 test steps is 12. P1 steps is 1024. This one is 22. Oh yeah, we also need to have grid sizes. So we have grid is so many values here. So we have P1 tests, grid width is 7, P1 test grid height is 7. So basically this is calls and rows. P1 grid calls is 70. Well, it's 0 to 70. So it's actually +1. So this one is 8 by 8. P1 grid rows is 71 as well. Good morning, Luke. 2, 2, 2, 2, 2. So I can do grid is new. I never even made a constructor for it apparently. So rows is test, P1 test grid rows, P1 grid rows. Calls is test, P1 test grid calls, P1 grid calls, and these need to be ints. So that is fine. That is the grid setup. So now we can start. We can do grid location. Start is 0, 0. So now we need to basically these are our obstructions. So let's do list grid location, actually hash set grid location corrupted. So in this case corrupted equals to boom, and we do parsed.take P1 steps, otherwise P1 steps. Luke says watching this while working, yeah, efficient. Let's see, so this is the corrupted, so now we need to do path finding. I should have probably just written that already. So we have also start end, and in this case end is new, column is grid dot columns -1, row is grid dot rows -1. So this is our end position, the other opposite side of the map. Okay, that is fine. Okay. Could probably have like a last a function for that in the grid as well. Now we need to do path finding. So int shortest path count grid hash set grid location corrupted start and end. Okay, so we have a priority queue as always. what do we need to do? Hash set grid location visited is blah. Priority queue. I think it just needs a grid location. Int q.enqueue start. Okay. Var p is q.dq. Grid get walkable neighbors p comma corrupted. For each, come on, for each, I guess, if not visited or contains n bum 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 bum. Actually, I can just do this. If n is end, return p. I also need to have the value in here. Pause, score steps like this. Boom, 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 boom. NQ, and this one becomes n comma p dot steps plus 1. Like this. That's fine. So let's see. Grid corrupted start and okay, it says 18. Let's see what I did wrong. After 12 bytes of corrupted location from your memory space, shortest path from the top right corner took 22 steps. Okay, let's print the map. Let's see. Grid dot print path. We don't care for this right now, and this one will just be corrupted, comma. Okay. Let's see if our map is correct. Like this. Yeah, it looks to be correct. So what is the path that we take here? That is interesting. So let's also keep track of the path. Just so we do a hash set. Now I can just do a list of. No, we can do a hash set. Grid location, path taken. This one becomes done. Like this. We can return a grid location. No, hash set grid location. So we can here return. Come on. This, and here we can just return an empty. Path is this. Path count, length, no count. And here I can do a print path of the path taken as well. Okay, so what did it do? So why was it 22 before? Okay, I made a boo-boo somewhere, but this is fine. No, it says 20, let's see. Oh, my map is 1 too wide. Haha. Never mind. So my map is 1 too wide. I did read it wrong. I thought it was 0 to 7, but apparently it's. What did they say? 6 and use up. Ah, okay. No, I was correct here, but this is what it should be. Okay, let's run this again. So and it needs to remove one because the first one isn't a step. So it's count minus 1. First one isn't a step. Okay. So now this should work. Boom, and we have our answer. Let's do this for part is false. It's probably too big to print. Whoop. P1. Woohoo! First gold star. That was easy. Let's see. Part 2. The historians aren't as used to moving around in this pixelated universe as you are. You're afraid they're not going to be fast enough to make it to the exit before the path is completely blocked. To determine how fast everybody needs to go, you need to determine the first byte that will cut off the path to the exit. In the above example, after the byte at 1 1 false, there's still a path to the exit. Okay. However, after adding the very next byte at 6,1, there's no longer a path to the exit. So in this example, the coordinates of the first byte that prevents the exit from being reachable are 6,1. Simulate more of the bytes that are about to be to corrupt your memory space. What are the coordinates of your first byte that will prevent the exit from being reachable from your starting position? Okay. Separate as a comma, no other characters. Okay. Yeah. So now I wonder, is this just look where in the future there is a byte that blocks the path that you found? Is that just it? Because let me see, parsed. How long is parsed? That's not much longer. Wait. So P2 would be for int I is corrupted.count. I marks is parsed.count plus I. I smaller than max plus I. If corrupted I path contains this console right. Blocks by blah at index blah, and I need to make sure that I write this in reverse. Why doesn't it like this? Not parsed like this. So this will be check.column, check.row to have it in their notation. Set next statement. Okay, that's fine. Okay, so this one will be the first then. Let's run the test input to see if it does the same. But it seems a bit easy for part 2. 1,2 at index 12. Okay, so I have a different. Two, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Let me see. Why do I have one before the one that they say? is this the last? Let's see. Do I need to do a +1 there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Ah, wait. I need to make sure that I can remove this, because removing this would still give us a path. That's a good point. Let's see. And that might be annoying because it might not work. So I should also put in like a best count. Let's see, I can do int max steps. So that will, for part 2, probably cut off the max path. If p dot take a note, count larger than this, return boom. So if we arrive at a path that's longer than what we say we need to exit, we don't care by default. Make sure we need this to get home. Var alt path is shortest path, grid corrupted. Come on. So we do also like hash set grid location extra is blah. So we do extra.add check like this. Start and path.count. That is our absolute max. If alt path.count is 0, we can do this. Else original path blocked by, but we found an alternative route. Okay. Let's see. I did this the other way around. Never mind. No, wait. Let me think. So it says if we add the 2,1, it doesn't work anymore. That is weird, because there is an alternative path there. Wait. Row 2, column 1. No. This is also like this uppercase thing. I can't actually exit early because the path might be longer, which is valid. This is annoying. Yep, I cannot do this check here. Ooh, that's so annoying, because that means that you can get very long search spaces. But yeah, let's see. Original path blocked, but found an alternative route, and then it's blocked there. Okay, 6-1. Okay, let's see what this means for the real input, because this will be annoying AF. Because if it now gets blocked, that means it does lots of big searches. That it means it becomes very inefficient. But yeah, Tapkawat says that one can currently block path, but other path may. Yeah. My instinct was, if it really becomes a blocked path, the search space will have to exhaust the entire map with all the options every time, which is annoying. So I wanted to have like an early exit in case it doesn't look like it's gonna work, but yeah. Okay, so it's still okay, but not great. So here you can see all of these. Boom. So it should be this. Oh. That's annoying. I wonder if we need to... I need to change my alternative route every time it's updated. So I should say, when we get here, what I should do, we do path equals path is alt path, and then we need to do extra.clear, switch over to the new path, and I think that's already okay. Let me think, because you might miss something else. I think, let me save this output and compare it. So I think it will return earlier now, because there will be other blocks to test. Let's see. Nope, still get the same thing. Is my grid the right size? Let's see. Yeah, I think so. What is wrong with my logic? Original path blocked there. Am I trying to be too clever, and should I just simulate it all? That's what I'm thinking now. Okay, let's try to be dumb and see if that changes anything. Let's see. Maybe chords in the reverse state. I already had it like column row format. And it worked for the test case. It showed the proper one, so I don't think that's the issue. Let's see. Hash set grid location local corrupted is corrupted. Let's stop running. Hash set. Boom. I think I can just do this. But now this will be a lot slower because it will do so many more iterations that it need to, but haha, okay. Because so now I should probably add some caching there to make it faster. Actually, I could also do this as a binary tree. That would have probably been smarter. If we do the brute force anyways, let me write it as a binary tree. Int min is corrupted count, marks is parse.count, -1, while min plus 1 the max. Check is max minus min divided by 2. Like this. Meanwhile, this is still running. Let's just kill that. So I can do local corrupted is parse take ix. Like this. Boom. Let's see. So if we don't have one, we need to go back. We do max is ix, and otherwise we do min is ix, and then we do this again. So now the max should have the first one that gets blocked. So we should do blocked path is take ix max. Why is it not liking this? Ah, here. Yes, never mind. Shortest path is min. Console that right line. I can just do this actually. Okay, let's see if we run this. Boom. And let's compare this to what we had. It should be lower than the value that we had. 2871, this is 2850, so this should be the answer now. Not the right answer. Let's see. Shortest path, blocked path. So I have 49. So everything up until here works, and this one doesn't. Interesting. Oh, it's an off by one. I should actually do min here because it's off by one index wise, because this is the amount that we take. Jesus, that was stupid. And the index also needs to be woohoo! Glad I realized that. Okay. But now I'm really curious why my logic of modifying the path didn't work. Okay. So that was okay. I don't like my solution because I think there's a better one. But yeah, because my reasoning was you have the shortest path. As long as no blocks are put in there to block it, it should be fine, and you find another path. But apparently you need to do it a different way. And I need to put this into a logic thing, like long binary search, long min, long max, func bool, long bool, check. Dapco says, the one I know is to go backwards and look for the first case where the path begins to exist. Let's see. I wonder if I should return min or max here, but that's fine. So I think I should now be able to do binary search min max min max. No, actually, probably, yeah. This should just give one value. So this one would be like this. Return all path at count is 0. This one will return min. I should long is this. Okay, no. Block index like this. In this case, we don't need longs, but might as well do it with longs. And this one becomes block index. Yeah, okay. So let's see. We expect this. Let's see if this still works. Oh yeah, this needs to be IX. Let's see. 851 at index. Yeah, because this one was incorrect. This is the actually correct one. Okay. So this is our binary tree search. And actually, now you still don't know which one of these resulted in true, but that's fine. It works for this case. And I should put this into like my helper functions. Could probably put it like an iNumeric. Public static. Can I do this T where T is iNumber T? Let me see. I've used this before, but I can't remember. Like this. So now I can do T, And now you do t this. T that. Does this work? Is it just t.1? Yeah, okay. So 2 becomes 2 times t.1. I have to be a bit clever here. I can't do that right. Could I make this static? Like, no, that's fine. So this would make it work like that. So now I should probably be able to do so now I could do min.binary search marks. Isn't long an I number? Public static. Ah, I need to do this like this. Okay, I forgot that. Yeah, cool. So now I can do this. Let's see. Not implicitly convertible down, you know that. Jesus. So if these are all ints, that should be fine. Doesn't it like that? That's annoying. So I would have to make like a func int bool check. And then I can do this. So then would it let me do this? Let's see. Okay. So it's annoying. So I have to define it like this, but you can't. Could this be bool check int x like this? It's annoying that you can't, that it can't infer this, because there's no way to do this differently, right? So I liked it up until that I couldn't write a lambda to put inside of this, which is annoying. Wait, I can do. Can I do this, or will it still? Yeah, cool. So if I do it like this, it works, but I would wager that it should have to be able to infer int based off of this. So this should be strong enough information for the compiler to say, okay, I will make sure this and this are ints now. But when I do it like this, it will say, okay, it can't. Can it? Okay. Not sure what was wrong just now, but okay, probably something else. So yeah, this is cool. I think this should still run, and I should probably have saved the answer for P2 so that it works here. Answer P2. Ah, this is it expects a string. Sure. That is fine. This becomes P1 and 2. We can do away with all of this. P1 is that, and then we can do this as well. So now we can say P2 string P2 is this. P2. This also becomes a string now. This was 6,1 if I remember correctly. Let's see, advent of code. Yeah, okay. 6,1. So that leaves, that should be okay now. We can remove this because we now have part 1 and part 2. I can remove this binary search. -1. Ah, I never saved this one. Never mind. Okay, so P1 is this. 454, what was it? 454, okay, let's run again. I should probably print out the P1 after, or before the rest, so boom. Okay, so now everything works and I have a nice extension function to do a binary search, which isn't 100%, but it's nice and it will save me some time next time. Because ideally, based on whether the last one returned true or false, I should return either min or max. So like the logic here. So bool check result. So I should do this. Oh. And here we should do check result. Max or min, right? So if the last one returned true, we return max, and otherwise we return min. So let's see, in this case we probably need to switch it around. No, this is good, okay. So if we change this, it should also work. But then the last one is off by 1. Oh no, it is a whole different thing. Never mind. It worked the way that I said it would. And that is important. Yeah. Okay. I need to put a caveat there. Make sure this is correct the next time you use it. Okay, so yeah, that's part 1 and part 2. All the values are filled in, it works. It's not bad. I'll go and check what everybody else did. So let's see your code submissions for today. For those that don't know, people share the code on my Discord and I go over them. Let's see. Amarte is first. Let's make this a bit bigger. This is all that's visible on screen, so that's fine. Thanks for the follow, Tycho 13. Yes, thanks for the follow, it's appreciated. Let's see. Setting up the grid. Map 2D, sure. So this should be in the header file probably, right? Or is it an extension function? Marta says, sleepless night, don't be too harsh on me for being stupid today. I would never. Because all my failures are streamed live, so who am I to judge, right? It's probably in the extensions thing, right? Okay, I need to go to, let's see. The extension with you look with search for symbol, it works. Yeah, there. Okay. Let's see. Get length of shortest path within bounds. Yeah, I should, with everything that I've done, I should have like a basic pathfinding thing by now. So I should probably also add that to my code and not write it over and over and over again. Boom, 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 step 0. What is your queue? It's just an int vector 2, okay. If it's for return steps to within bounds is valid. What does invalid do here? Okay, I'll check that back. That probably checks against like the blockers. Well, I wrote it today, this morning, didn't have anything before. Okay. Yeah, I have like my, I have a function that I pass to the grid that gives me the directions, but I also pass like the obstacles there. So it will check in the thing that returns the possible locations. I combine it so I can pre-filter there, but it doesn't matter left or right where you do it. I have to check it anyways. Let's see. Okay. So you just grow it, yeah. In this case, you just grow it one by one. I should have probably also done that, but then I can't do my binary search. Yeah, my binary search is probably more efficient, but it does have to create a new hash set every time. This one, it can just like memory-wise, this is fast. Is more efficient. I have to do lots of memory operations. This one just adds one, but then you have to do the whole pathfinding. So I think the binary search is probably still faster, but I'm not sure. I should benchmark it. Yeah, it reads really clearly. So good job. Let me. Good job there. Let's see. 9berry. Relevant points is point stick after time. Sure. And by the way, when I was reading the problem set, I thought that you would have to simulate each step and then add a lot of block to the map so that you would go through it as blocks come down so that it would alter the path at every step. That's something that I thought they would do, something like that. Nineberry said I thought the same, yeah. Maybe they do that tomorrow, you know. Get shortest path, get shortest path. This also just goes, okay. So for both of you, if you want to optimize it further, I think a binary search will help you cut down the amount of pathfinding that you need to do. Only calculate new path when the point is in the last path found. Okay. I did that and it didn't work for me, but maybe I had a different bug because that was the first attempt that I wrote. Interesting. Because this is literally the approach that I took last time. And I didn't understand why it didn't work, so should I revisit that again? Now I'm annoyed. Works good for me, reduces time from 10 seconds to 25 milliseconds. Yeah, I can, let me benchmark this, stopwatch dot get timestamp to start is this. To end is this. Stopwatch, get elapsed time, Q to start, P to stop. It took no time. That's total milliseconds, total nanoseconds. Wait, what? Where's my binary search? Do I do it? Print path, check. Okay, my code is instant. I don't know what's happening. Did I? Ah, P2 end. Never mind. I was like, this is not possible. Okay, that looks that looks more realistic. No. See, 176 milliseconds. So that's, no, it's not more efficient. One 40 milliseconds. If you combine this with this logic, if it works, because I still need to, let's just do that for now. Because I'm annoyed that it didn't work for me. And I don't understand why it works for you. So for int I is corrupted at count. Max is parsed count. I smaller than max. What am I doing wrong here? Int ix is corrupted at count. Why is it complaining? Ah, not for 4. Nineberry says, need to go, thanks for streaming, see you. Bye bye. Amate says, my brute force is 180 milliseconds, but I have no prints. Maybe those are the reason for the bigger time. I time it after the prints, so the prints are not involved in the time. So let me see. I can corrupt the shit out of it, so it doesn't matter here. So I can do corrupted.add parsed ix. If so, this new corruption grid location new corruption is like this. If path of contains new corruption, reevaluate. So now we do alt path corrupted start end. If alt path of count is 0, we can do this. See, I get a different result here, which is weird. I wonder how this is possible. Because start and end. Wait. Oh. I overwrite end. Oh, Jesus Christ. Was that the same issue the previous time? Nope. The same issue that I had back then. See? So somehow it feels like up until this path it can still find a route. Which is really weird. Because it won't so in my input it seems that there is a I wonder how that's even possible. So yeah, for some reason this doesn't work for me, but I found the solution and it's fine. Works for others, not for me. I'll try somebody else's code with my input later to see why. And this is all the same, we already saw that. Yep, let's see, did somebody else post their code? Luke also posted their code. Was Too lazy to think, so I brute force part 2, fun puzzle, maybe I create visualization when I find time. I would recommend that. Ah, Luke, your code is not on the server. Oh, was that because you renamed the day? Okay. Let's see. Path available. Marta says, I still don't get how does binary search work. I mean, you ask it for the first location and binary search may find another one, not the first. Okay. In this case, you need to find the first blocked path, right? So what you do is you have your range of everything that can be added. You take half. If that path is blocked, it means that the path that first blocks it will be before that, because it can't be after it, because this one already blocks it. So you can eliminate the top half of your search space. So now you have that second half, and you go into the middle again. So you check, does that middle record, is that path still blocked? If it's blocked, you again can eliminate the top half of that search space. So if you do that again and it is not blocked, that means you can eliminate the bottom half of the search space, because there will be more below that are all unblocked. So then you go into the bottom half again and you check, and you do that until the min and max just becomes next to each other. So you will have the one that passes your test and the one that doesn't pass your test. And depending on which side you want it to be, you can then take that value. So that lets you, as long as you can have like an ordered problem. So like there's a point where there's a switch made and you need to find that point. If you can test for that, the binary search is extremely efficient. It's like the dumb way to do smart brute forcing. And actually, youtube.com, CS50, I think it's this one. Oh, there's usually like a big one. I think it's algorithms. So they will have, yeah, they will explain binary search here. So he makes it very visual. Like I say it with words, but CS50 has a good explanation on that, and also for other stuff. So it's an interesting one if you want. Let me think. What were we doing? Alright, we're checking Luke's code. This just takes the linear approach there. It's fine. Okay. Yeah, I saw that. You're living in the future. Cheese. Time taking for part 2. That's fast. How fast are your solutions? Let's see. About 250 minutes. Fast enough for me. You brute force each obstacle after another. No, that would take seconds. I have a shortcut, but C# has some overhead. Okay. Wonder how fast my solution is in C#. You haven't posted yours. Brute force each obstacle takes around 160 milliseconds in release, 3.5 seconds in debug. Okay. I'm so doing it on my work laptop. Also, I don't want my personal stuff to be in here, like my GitHub. So I haven't uploaded my code yet. Okay. Let's see. It's bright. not used to. I'm so used to dark mode that a white screen is so much brighter. Let's see. So the downside of very short variable names is that it becomes a bit more difficult to decode. So this is queue, bounce checking. If there's something in there, continue. This is the visited stuff, okay. So what does you do here? This just brute force adds every direction there and it will just skip. Yeah, usually I would do this check for everything that you do in here so that you don't enqueue the stuff unneededly, but yeah, it's fine. So this one will take the full list and then go backwards, or? At least that's what it looks like here to me. So he starts with everything and then just works in reverse. I'm having a bit difficult to read this, but if somebody else spots the smart thing that happens here, feel free to let me know, because I didn't know, didn't understand this part completely. I'll have to ask him in Discord. Let's see. Using more of a both identifiers would make it easier to understand. Yeah, exactly. Yeah, I plan to clean up everything and have it on GitHub. I think I've cleaned up until day 10, a week worth of code to go. By cleaning up, I mean human readable code. Is that the algorithm we know from AOC 2023? They find the node separating subgrass. They've completed an AOC before 2023. I died on day 14. Been wanting to completing it though. I should attempt 2023 again when I'm done with 2024. Yeah, same for me. I want to go back and do more. Puts all the obstacles on the grid and then removes obstacles one by one starting from the last list and returns the answer when the path is found after removing that obstacle. Okay. So that's less efficient than what I'm doing, I'm pretty sure. So this is just the brute force, but starting from the back. And depending on where, actually given my answer, yeah, okay, in this case it's fairly at the back, so that saves a bunch of time. So let's see, we can count actually. Steps from back, so this would be parse.count minus block index. Let's see. Ramrun, yeah, that's Advent of Code. Welcome to the stream, Metalim. Ramrun is this Advent of Code challenge. So I've done Advent of Code today, and I just finished it. I was just going over some code here. So I want to actually check how many times we have to do this. So let's do int search count is 0. So we can do increment search count. we have to do search count checks. Yeah, it's the name of the task, indeed. So let's see. So yeah, my algorithm is at least a lot more efficient. So if I were to go from the back, I had to check 601 paths, and I only had to do 12. So binary search for the win. Though I still think that like the blocked obstacle checking, there must be something that I do wrong there. So I will still have to go and check that. I will test somebody else's input if I can and see if it works there, or maybe share my input with somebody else and test it. But yeah, so as you can see here, the binary search is highly efficient to find part 2. So yeah, I think that's it. Boom, 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 boom. So I might have a reason to post my code on Reddit today. I don't think I've posted it in a few days. So let's see if we have somebody else to raid that does advent of code. Already raided her once, I think. Or didn't I? I don't know. Let's see. Let's trigger the ads for both. Let's see. Ah, there's no ad here. Let's see. So let me, okay, turn off Spotify. Let's see. First opus. Switch to hex tree and miss your binary search implementation. Ah, no worries. Let's see. Are they streaming? Seems like they're not there. Let's do this, but
no, I do smart moves. But that's so much effort.
Okay. I'll have to rewatch and see what you did. I can quickly show it while stuff is loading.
Do it like this and it's so much easier.
I made a binary tree function, which basically a binary search.
We might need smart moves in part 2.
And I probably need to mute this for a second while I do this. I made a binary search helper, and I abstracted it to numbers so they can do it with int and long and etc. And I explained how it works. But basically it just takes like everything after we've processed, take a sample there, check if the path is blocked. If so, we discard the upper range and do a new sample there halfway through. So that brings us down to 12 things that we need to do. So yeah, that's a quick recap there. Let's see. Oh. So I want to rate one of these two. This one already has a lot of viewers, so let's just rate this guy.
Is the rest of the queue.
So thank you for joining, and let's go rate and say hi and do another one tomorrow. So bye bye.
Also need scores now. I need the scores, which is a map of